Hi everyone. Today I'm going to continue this section 2.1. Uh, as you remember, last day I was talking about at the very end. I was talking about two-way tables. Um, Especially these two-way tables plays a huge role in our course because uh, two-way table you will get a full exam question from these two-way tables. I think I need to explain a little bit more about these two-way tables, especially how we can find answers to specific questions. Right, so let's go through the last few questions we discussed um, based on this two-way table. So if you remember this question, it was about proportion of students in this sample are in a relationship. Student uh, in the sample are in a relationship. So this is the easiest way to solve this kind of problems. Right. In this question, you can split this question into into two pieces. Okay. First part of the question is this. You can forget about the what proportion of this piece. So this is the first part of the question. This is the first part. Okay. And let me use another color. This part is the second part. Okay. Right. So based on this kind of questions, you have to identify what is the first piece of this question and the second piece of this question, and then need to find the corresponding numbers. So let's check these numbers. Students in this sample. So where is I mean where we can find these students in this sample. So this is the students in this sample. That's the total, right? Sample size. Then in a relationship, how many students in a relationship? So what is the frequency of this piece in a relationship? So where I can find in a relationship, in the relationships are here in this row. So the total, regardless of the gender, total is this, right? So you have to do this. You have to divide the number or value belongs to the second piece by the value or the frequency belongs to the first part. This is the way to this is the easiest way to solve these kind of two-way table problems. Okay, so it is 42 over 169. Let's look at the other question. This one. What proportion of females in the sample are in a relationship? So two parts. Females in this sample, that's the first part. Okay, that's the part number one in this question. And the second part in the same question, the second part is in the relationship. So you have to find the corresponding frequencies for these pieces. So for the first one, always goes to the numerator, goes to the denominator, and part 2 value goes to the numerator. Okay, females in this sample. So how can I find these female count? See, female count, it's right here, and the total of this column gives me the female count, which is 107. Okay, then are in a relationship, in this row, right? So this row cross with this column, which is this. This is the in a relationship for females, right? So it is 32. See, this is how we can find the number. So you have to use your calculator to get the percentage. Okay, oh, there's another question. Okay, right. We can use the same trick that we used the previous two questions. What proportion of people in a relationship in the sample are female? This is always about sample. So, how many people in a relationship? That's the first part of this question. In a relationship, we have 42, right? So this part, oh sorry, not 45, it is 42. It goes to the denominator. In this sample are female. So the female count belongs to this inner relationship row, which is this one, right? 32. So it gives me this. I hope you can understand this, understand the situation and this trick. This is the easiest way to go through these kind of problems. Okay. All right. Uh, let's see. Right. Two-way tables. There are a few things you should remember. If you noticed in our previous questions, the proportion of females in a relationship is not same as the proportion of people in a relationship. These two, if you noticed, I mean, if you remember, these two, they are different. The value wise, they are different. It seems to be same, but they are different. Let me circle it for you. These two pieces, these two. For the females in this relationship, I mean, proportion of females in this relationship, it is 30%, and proportion of people in the relationship who are female, it is 76. Why this happens? This happens due to many reasons. Uh, these two, although it seems similar, it is statistically it is different. Okay, so your answer directly it should based on your question. Okay, so wording matters in this kind of questions. You have to be careful when you are reading these kind of questions. Okay, right. uh, right, there's another one. What proportion of males in this sample are in a relationship? So what proportion of male in this sample? So male in this column. So I can say 62 is the count, is the total for the male in the relationship. So in the relationship, this row and this is the value 10 out of 62. Okay, so this is the value. And also, if you check those two, men and female proportion. If you consider the men and female proportions, 30% of females in this sample say they are in a relationship. Okay, 30% of female in a relationship. If you divide 32 by 107, you can get that number. 16% of males in this sample says they are in a relationship. That means this number. Okay, so they are different. What happened? What has happened? Actually, it can happen. Okay, again, there are many reasons for that as well. It can be some natural situation. For example, uh, females for the females, their partners or the person who has a relationship is can be outside this class or outside from outside this sample. So it can be a reason, right? It can be happened. And also maybe although we consider this gender binary, in general, in reality it cannot be binary. So this kind of based on these kind of situations, these values can be two different values. You ask things into, although you ask things in two different ways. Okay, right. uh, Difference in proportions. If you need to find the proportion difference, then proportion difference between two categorical variables, you can do it. Okay, difference in proportion is difference in proportions for one categorical variable to the other categorical variable. Okay, here we have two categorical variables, male female is the one categorical variable, the other one is relationships. So we can find the particular difference as we want. For example, in our previous question, proportion of females in a relationship and proportion of males in a relationship. So proportion of female in a relationship we denoted by this piece, this one denoted by PF hat. Do you remember the hat notation that I talked about last time? Whenever we use hat, that means it is about uh, sample notation. Okay, it's about sample. So P hat, that means it's a proportion about female. Proportion of males in this sample, we use simple P M hat for male. Whenever you need to get the difference, you can use either way. Based on this question or based on this focus, we have considered the proportion of female in this relationship to the proportion of males in this relationship. So order is P hat F minus P hat M. So this is the answer, and you can see the answer is a positive number. Okay, so positive number, that means proportion of females in this relationship, in a relationship, is greater than proportion of males in the relationship. Okay, right. Here is another example to understand this difference in proportions. We have considered proportion of students in a relationship who are female, in a relationship who are female, which is, now you should be able to find these values. Proportion of students in a relationship, this one, who are female. So 32 over, this is 32 over 42. The other, so we denoted it by using P hat R. P hat R. And the other one is proportion of single students who are female. So single students, which is who are female. So who are female, this column, sorry, not this column, single, student single, this row, which means denominator is 108. In this one, females, this column, which is 63. Okay, so we denoted it by using P hat S, single. This is our relationship, S for single. If you need to find the difference, you can simply take P hat R minus P hat S. Okay, these are the numbers, and you will get a positive number again. That means proportion of students in a relationship who are female is greater than proportion of single students who are female. Okay, right. Then visualization. It's super nice to see, super nice to learn how to uh, visualize these two categorical variables. We have a separate set of graphs to visualize these uh, two categorical variables. One is side by side bar chart. This is a bar chart. Okay, you know what is a bar chart, right? In a bar chart, we have separate bars for each values, same as single categorical variable. And this axis, y-axis, it is about frequency. Okay, it's frequency or count. So these are the values. These are the values for one categorical variable. They have considered relationships for for x-axis, and then the other categorical variable considered as a legend. A legend. That means we first draw one categorical variable. So this belongs to, I think, yeah, this belongs to female. This is a dark color bar chart, and at the same time, aside we draw the bar chart for the male. Bar chart for the male. See this one. Because, for example, we have male and female for in relationship. We have male and female for it's complicated, and male and female for the single. This is side. See, side of this bar, we have drawn this male frequency related to inner relationship. So we call this side by side bar chart. Okay, this is a side by side bar chart. You don't need to do it. You don't need to draw this by hand. You can easily use stat key to draw this. Okay, right. The next bar chart type is a segmented bar chart. Same as before. Here the difference is, instead of side, we draw the other part on top of the previous one. For example, here you can see. I'll use blue, same color. Here, same as before, we have used dark color for females, and on top of that, especially for example, in the relationship, we have females here, and on top of that, we draw male who are in the relationship. So the width of this bar doesn't change, but the height, it differ from the previous one. So likewise, we use side by side bar charts and segmented bar charts to visualize two categorical variables. And also, same as the side by side bar chart, we use a legend to show what are these colors, so that it is easy to understand what are these colors, what they represent. So this is an exercise for you guys. Just go to the stat key and try to draw segmented bar chart, okay, based on student survey data. Just try this. You have to try this. Okay. Variables year and sex. Okay. Student survey data. Once you go to the stat key, in the first column, two categorical variables. Click on two categorical variables, and then from the dataset drop down menu, the left corner, you can find survey data, student survey data, and from there try to draw this segmented bar chart. Okay, all right. Summary of this two categorical variable is, we talked about two-way tables, very important. Okay, and we consider the difference of this proportions. For example, female who are in a relationship minus the proportion of males who are in a relationship. Okay, then for the visualization purposes, we use side by side bar chart like this, and we used segmented bar chart as well. It is like this. So height of each bar segment represents the frequency of that particular value category. Okay, right. I hope you can understand what is going on. That's all for section 2.1. Um, it's about categorical variables. So if you have any questions, please don't wait and talk to me. Just shoot me an email or come to my office hours once we come back to normal in-person classes. So please go through this section 1 again and try to start your homework. Homework 2.1 is already uploaded on Moodle, so you can go there and start your section 2.1 homework. And I think already I set the due date for 25th. So start it and you can upload it same as before. Okay, so that's all for section 2.1. Then I'll move to section 2.2. Okay, in section 2.2 we have to talk about quantitative variables. So first we'll talk about one quantitative variable, and they are shapes and center. Shapes and center. So same as before, we are trying to talk about what to do with these quantitative variables, then how to visualize them. We have a different set of visualization techniques to work with one quantitative variables. Especially we will be talking about shapes and some kind of measurements under this one quantitative variable. All right, I hope you guys remember this Hollywood movie data set. Okay, so we have columns, they have names. See, from this table you identified these are uh, quantitative variables, right? Because we have numbers, right? Simply we have numbers, so these columns are quantitative variables, right? First, visualize. How to visualize this? For example, using a dot plot. This is a specific case to visualize single quantitative variables, because dot plot can draw, it has only one axis. It's pretty similar to like frequency charts, but here it has x-axis and y-axis, but this y-axis always represents the count. It's not about frequency, it's about count, how many. Okay, there is no y-axis, it's just count. It just count how many similar numbers they have. Okay, let's check this example. In this dot plot, same as it shows here, dot plot, it is a dot, it's full of dots. Okay, each value is represented by using a dot. Okay, if we have more than one occurrence, then we have to stack that dot on top of the existing one. See here, under 0 we have just one dot, that means there is only one value. But the next one, there are many dots, that means in this data set, this data set is world gross. I think the name is exactly same as this axis. Here we have multiple occurrences for this particular value on this axis. Values means values on this axis: 600, 800, 1000. Here 200. See how many? 1, 2, 3, 4, 5. There are 5. Same 200 values. Okay, right. uh, there's a one drawback in this dot plot, that is it is hard to read a particular number. For example, this number right here, what is the number belongs to this dot? It's not 1000. 1000 is right here, right? It's right here. But what is this? It is hard to measure. Okay, so that's the drawback. And also when we have a large data set and we draw this dot plot, it seems pretty unclear. Okay, so those are the major drawbacks, but still we use this. It's super helpful for small data. And the other technique is histogram. Histogram is a big deal. It plays a huge role. Okay, so histogram, we draw histogram for quantitative variables only. Okay, it is similar to the bar chart, but there is a difference between bar chart and histogram. In histogram, we do not have gaps between bars. See, they are tied together. If we have gaps, if we don't have values in that particular block. Okay, for each block we don't have values. We have a scale. Let's say this is the x variable, so we have x variable values on this x-axis, and same as other graphs, y-axis shows the frequency. Y-axis shows the frequency. Okay, right. There is a, yes, there's a slide to compare histogram and bar chart. In this picture, or is this a bar chart or a histogram? See this, we have x-axis, we have a histogram. Why? Because this x-axis we have values, we have continuous values instead of categorical values, right? And bars are tied together. Okay, so this is a histogram. How about this one? It is a bar chart or a histogram. This axis represents values of a categorical variable. So this is a bar chart. See, each bar has a particular value, a qualitative value, not a quantitative value. And we have gaps between bars. See, so this is a bar chart. So you should be able to clearly differentiate what is a bar chart, what is the histogram. Okay, bar charts for categorical variables, histograms for quantitative variables. Yeah, in the next slide, you can see I have clearly mentioned those things using bullet points. A bar chart for categorical variables, so categorical data. No numeric, x-axis has no numerical values. A histogram for quantitative data. Okay, that's the difference. And x-axis is numeric. It represents numerical values. For categorical variables, bars equals the number of categories. In bar chart, number of bars represents the values in that particular category. Okay, it is fixed. For quantitative variable, bars in this histogram, it is up to you. You can decide how many bars you need to set up, or you can decide it through the software, or software can automatically decide how many bars need to use. Okay, all right. uh, I think that's more than enough for today's discussion, because the next part about shapes, I need to have some time to go through that, and I think up to this point is enough. All right. Uh, if you have any questions, please let me know. In section 2.2, I was talking about quantitative variables and how to visualize them. We use here we use three things. We use dot plot, we use and we use histograms. Actually, two things, and then we compare bar chart with histograms. Okay, those are the three things. All right. I hope we can meet in person next week. So as I mentioned, if you have any question, please let me know. I have already opened your section 2.1 homework. So please try to start that homework. All right, guys. Have a nice day.